Hello everybody, this is Digital Blackboard by Sachin P. Nagmote. In the last video, we have seen the stability of control system and determination of stability by using the coefficients of characteristic equation. In this video, we are going to discuss the problems on Routh's stability criteria. So we know that we can determine the stability just by using the coefficients of characteristic equation. So A0, A1, A2 up to AN, these are the coefficients of the characteristic equation given. Okay. Now, if the characteristic equation is given and if we arrange these coefficients of characteristic equation in the format given by Routh, it is also called as Routh's array, we can determine the stability of control system. Now, in the last video, we have also seen that the first two rows of the Routh's array has to be filled by using the coefficients of characteristic equation, and the remaining rows has to be filled by using the formula. Now, the formula is already we have discussed. So, how to calculate the values of B1, B2, B3 means how to fill the third row, then how to fill the fourth row, and so on up till until we get the 0. Okay. So we have seen that if ABCD is the entries of first row, EFGH entries of second row. So how to fill this third row? So it is simple. So we first entries, let the first entry is A1. So A1 can be calculated by just E into B minus A into F. Similarly, B1 can be calculated by using the formula E into C minus A into G upon E. Then C1 can be calculated by using the formula E into D minus A into H upon E. Okay. And if there is no entry, then it is 0. So D1 became here 0. Okay. Now the next entry, how to fill the next row. So let it be E1. So how to get the value of E1? So in the denominator, we have to put the value of A1. Okay. Then A1 into F minus E into B1. Similarly, what will be the formula for F1? So again in the denominator A1, and then F1 will be equal to A1 into G minus E into C1. Okay. Now next entry is G1. So again in the denominator we are having A1. So how to get the value of G1? So A1 into H, A1 into H minus E into 0. Okay. So such we can get the all the values of entries in all the rows. Okay. Now one thing is very important when we are filling the rows. So in the denominator always the first entry of just above row we have to put. So if you want to fill the rows of S1, okay, S1 row if you want to fill, then what will be in the denominator? Always in the denominator there will be E1 for all the entries. Okay. So we fill all the rows one by one, and finally we get the Routh's array. Now after getting the Routh's array, we have to observe the first column. So after observing the first column, so which thing we need to observe? So just check the sign of first column of Routh's array. So if there is no sign change, it means now in this case we are having all the entries in the first column having positive sign, and there is no sign change. So if no sign change in the first column of Routh's array, then the system is called as a stable system. And if there is any sign change in the first column, then system is said to be unstable. And the number of sign changes in the first column determines the number of poles lying on the right hand side of S plane. Okay. Now we are going to solve the problem. Now the first problem is the characteristic equation of a system is given below. Find whether the system is stable or not using Routh's criteria. So s to the power 4 plus 6x cube plus 21s square plus 36s plus 20 is equal to 0. This is the characteristic equation given to us. Okay. Now how to form the Routh's array? So it is very simple. So highest power is 4. So here on the left hand side we have to take s to the power 4, and then the decreasing order s to the power 3, then s square, then s to the power 1, and finally s to the power 0. Okay. So we have to put this power of s in the left hand side. Now how to fill the rows? Okay, the first two rows must be filled by using the characteristic equation itself. So what is the coefficient here? So you see here the coefficient of s to the power 4 is 1, the coefficient of s to the power 3 is 6, the coefficient of s to the power 2 is 21, then the coefficient of this s is 36 and s to the power 0 because no s term is there, so coefficient is 20. So alternately we have to fill the rows. So alternately we have to fill the rows. So 1, then 21, then 20. Then in the next row 6, 36 and 0 like this. Okay. So we got the first two rows. Okay. So 1, 21 and then 20, 6, 36 and 0. Okay. Now how to fill the s to the power 2 row, means how to fill this row. So we know the formula is already available with us. So according to the formula, b1 is equal to a1 into a2 minus a0 into a3 b2. So we know already the formula, so we can easily fill the s to the power 2 row. So this becomes 15, 20, then 0, then 28, 0, and finally we are having 20. So finally we got the Routh's array. Okay. So after getting this Routh's array, what we have to do? We have to observe the first column of this Routh's array. So after observing the first column of this Routh's array, we came to know that there is no sign change. There is no sign change in the first column. So it means simply the system is stable. Okay. So the question was, the characteristic equation was given and we have to find out whether the system is stable or not using Routh's criteria. So we got final answer that system is stable here. Okay. Now next problem. So in problem number 2, comment on the stability of following system using Routh's stability criteria. Now here the system is represented by a block diagram and we have to comment on its stability. So now we know if you want to comment on the stability using Routh's criteria, so we have to obtain the Routh's array, and for Routh's array what is the requirement? The requirement is of characteristic equation. So first of all we have to find out the characteristic equation. So characteristic equation is nothing but, what is the characteristic equation? So it is nothing but denominator of transfer function equated to 0. That gives us the characteristic equation. So simply, so 1 plus g of s into h of s is equal to 0 because the closed loop transfer function of closed loop system is given by g of s upon 1 plus g of s into h of s. Okay, because here we are having the negative feedback. So 1 plus g of s into h of s in the denominator. So equated denominator equal to 0. So it can give us the characteristic equation. So we are having g of s multiplication of these two blocks and h of s is nothing but equal to 1. So after solving this, we are getting this equation. So we got the characteristic equation 2s cube plus s square minus 3s plus 10 is equal to 0. So we got the characteristic equation here. Now arrange this characteristic equation coefficient in the Routh's array. So here in the left hand side, what we need to put? So highest power, then in the decreasing order. So s cube, then s square, then s to the power 1, then s to the power 0. And how to fill the first two rows? So 2, then minus 3, and then 0, and then 2, and the alternate entry is minus 3, and then the alternate entry, that is nothing is there, so 0. Then how to fill the s square row, second row? So 1, then 10, okay, and then 0 because there is no term. So how to fill this remaining two rows? By using the formula. So formula is already available with us. Okay. So by using this formula, we can fill the remaining two rows. So it comes minus 23, 0, and finally 10. Okay. Now we got the Routh's array. Now after getting Routh's array, what we need to do? We have to observe the first column. And in the first column, we can see their sign change because 2 sign is positive, then 1 is again positive, and there is one sign change, that is minus 23. So positive to negative is first sign change, and again minus 23 to plus 10. So this is second sign change. So we are having first thing, it is clear that there is sign change in the first column. So system is unstable. Okay, system is unstable. Okay, and how many sign changes are there? So positive to negative is the first sign change, and negative to positive is second sign change. So as two sign changes are there, so two poles will lie on the right hand side of S plane. So we have commented on the stability by using Routh's stability criteria. The system is unstable, and as two sign changes are there in the first column, so two poles will lie on the right hand side of S plane. Okay, so we got the answer. Okay. So hope you got the better understanding how to solve the problems using Routh's stability criteria. In the next video, we will solve some more problems and the complicated problems of Routh's stability criteria. So please like, share and subscribe, and for any query you can contact suchinnathmoti@gmail.com. Thank you very much.